This is an introduction to programming, syntax, definitions in Java. It's kind of a long chapter, and I'm not necessarily going to spend time on each and every little part. The thing I want to stress is that it's a very big, high-level overview. It's sort of like if you're visiting Hawaii and you took a helicopter tour, right? And you get it way up high, and the tour points out all these different important points and plantations and volcanoes and black sand beaches and whatever, waterfalls and all the cool stuff, but you're not actually visiting those places. You're not actually doing the road to Hana or whatever, which you should not ever do. But you're just seeing it from a height that lets you kind of take it all in and get a feel for it to decide maybe what you want to look at later. So the thing here is with this chapter 2 is just keep in mind that while I'm going to be talking about syntax and typing some into Eclipse, which you can follow along too, it's just to get you kind of this big high-level overview. I do not expect that as a result of going through these 30 slides or however many there are, that you all of a sudden now understand every bit of Java syntax. We will come back and cover everything in sequence with activities and examples and homework and stuff as we move through the semester. So just sort of enjoy the ride, but don't stress about missing the details, because the details here are not super important. We'll come back to them and cover them in detail, or in more detail, enough detail. And you guys have all had a previous programming class, so to some extent this is some review here, so I'll move over it fairly quickly. But programming is the art and science of telling a computer what to do. You do it by issuing detailed step-by-step instructions. Those instructions will be in some valid language syntax like Java, and the order of the instructions is important. Most programs work top-down, so you have to put your instructions in a correct order that will get you the result that you want. The different programming languages, that same table, but Hello World in 3 languages. There are so many languages. I tried to get an exact count when I was putting the slide together, and I came up that it was at least 256 distinct languages. Lots of those are no longer used. They're old, but one of the surprising things is old languages, for the most part, almost never die. There are still languages that were used in the 50s that are still running on servers somewhere and require somebody who understands the language to maintain them when stuff goes wrong. So you know how I showed you that programming language demand on the first day, just to show you that, hey, Java's the top language, you made a great choice, this is going to look great on your resume, etc. I could have typed for older, dead kind of languages you would think would be dead, and you'll be surprised because you will often see dozens or even hundreds of job listings for people who know how to program in COBOL or Fortran or something else that somehow is now an undead language of some sort. Yeah, unfortunately, none of the languages is English. That would be nice if that was the case, and maybe we're moving towards that, but much more slowly than any of us might hope. Analogy-wise, programs are a lot like recipes, if any of you cook, in that they're inputs, ingredients, and you need all of them and in the correct amount and type, which is sort of like the right syntax. There's a procedure, a process. These are the step-by-step instructions that have to be followed. And programs also have these step-by-step instructions, and doing them in order is crucial. If you get these out of orders, you do not get, as in cooking, you do not get the desired output or result. And in programming, if you misarrange the statements, you will not get the results you want. In fact, the program might not even run. Input can take the form of various types of data. It can be numbers, it can be Boolean true-false values, it can be structured data, class-based data, and perhaps other forms. Well, certainly resource files like sounds and images would be considered input. So lots of different potential inputs. Sometimes we just type data into the program to get stuff to work. So if we type stuff into the program like the number 7, the word true, which is a Boolean value, the number 3.141563100, or hello in double quotes there, those are actual or raw data values. And the term for that in computing is they're literal values. What they are is literally what their value is. They are not variables that point to some literal value. Rather, they are in fact values, complete values in and of themselves that you can use. Frequently, we're going to create variables to hold these values. Just like in other languages, to some extent like in spreadsheets where you put values in specific cells and the cells have names like A6 or whatever. In most programming languages, we can create named variables, put data in those named variables, and then use those named variables in place of literal values when we write formulas or procedures of some sort. So here are the rules I alluded to earlier. Named variables in Java can have letters, numbers, the $sign, and the underscore sign. They may not start with a number or the $sign, and they may not contain any spaces. So that's the rules incomplete. There is no practical limit to the length of variable names. They are strings, so I think they might be limited to 2 billion characters. But you know, you get a variable name of a couple million characters, and that will take you a long time to type in. You want to keep them pretty short. I mean, naming variables is itself almost a little bit of an art form. You want it to be clear so that when you read it, you remember exactly what it is, or when you want to use it in a formula, it comes to mind easily because you've named it so obvious that you know exactly what its named is, even if you haven't used it in days or hours or whatever. You want to keep it reasonably short and simple so that you don't frequently mistype it every time you're trying to use it. And there's also a benefit to consistency. If you use a consistent naming pattern, that will help you name variables as you're coding and also help you remember them. And if you're working in a team and you guys could agree upon some sort of common naming guidelines, then that will help you with everyone else's code as well. If everybody's following a basic idea. There are reserved words in Java. They're on page 29 of the textbook, although I'm sure you can Google them. And these are words that are language statements like if, while, class, public, main. The kind of the stuff that we've used so far. If you look at the program, if I can find it, public is a reserved word. You can't name a variable public because public is already used and it means something. I've got a bunch of examples in the Keynote slide. Just the task to think through these potential Java identifiers, which could be variable names or object names or class names, to see which ones are legitimate, which ones are not legitimate. Let's just run through them really quick. 4 of these are not valid. So remember that the rules basically are you can use letters, numbers, and 2 symbols, the underscore and the $sign. No other symbols, no spaces. You cannot start with a number, and you cannot have spaces. I mean, essentially a space is an invalid symbol. All right, so just going kind of top to bottom. First step duration, that's not going to be valid because it starts with a number, and you can't start with a number. Second one, boil time with an underscore in there. Yeah, that's fine. It starts with a letter. It contains all valid characters. Good to go. Very closely boil time with a space in between the L and the T. That's not going to work because you can't have spaces inside of the variable name. If you got rid of that space, that would be a perfectly good variable name. And it's similar in style to cups of sugar. So this uses the Java recommended camel case capitalization, which we'll talk about in a bit. For is not going to work. For is a reserved keyword. You cannot use reserved keywords that Java has already allocated to itself. Name for hop2, it's kind of long, but works fine. It does not follow the Java's recommended capitalization style, but you don't have to. Anything that's just a recommendation, you should feel free to ignore and maybe even enjoy ignoring some of them. All right, sequence 4. If it was just sequence 4, that'd be great, but I put it in quotes, and quotes means that It's not an identifier. Actually, Java sees that as a literal, an actual piece of text to do something with. So you cannot use something like that as an identifier. Recipe name, that works fine. Bottle condition with the symbol at the beginning, yeah, that works fine. Oven temperature in Fahrenheit, or however you would read that, that works fine too. So if any of these are confusing, another way to tackle it, I mean, if you're unsure, for instance, if something is valid or is not, it could be, but you don't remember exactly, you could just fire up Eclipse. So if I wanted to test a variable name of some sort that I was thinking of using, we'll get to this in just a second in the overview, but you specify a data type like an integer number is a data type, and then after that you press the name of the identifier. So, for instance, sequence 4 works fine. You can see in Eclipse that it's not underlined in red, and it changed color once we got past it, indicating that Eclipse likes it as well, and it's an identifier. It's coloring it kind of a dark blue. But if I put that in quotes, now Eclipse does not like it, Java compiler does not like it. If you hover over it, you'll get a message like syntax error, invalid variable declarator, which is just saying this violates the rules for a valid Java ID. If I get rid of the quotes, obviously everything goes away. Case sensitivity. So Java's case sensitive. That's the bottom line. What that means is Java looks at capital letters and lowercase letters as two distinct characters, which they are. So if you capitalize a letter in a variable name and then try to use it later, you have to be sure not only that you spell it correctly, but also that you capitalize the letters correctly. Java keeps track of your data using one of a number of data types. So you can store data in Java variables to work with, but you have to tell Java what type of data you are going to work with that variable. That is a little bit different than simpler scripting languages that kind of figure out the data type on the fly and are flexible like Lua. Java's not flexible like Lua. Java will require that you not only specify a data type, that every time you use that variable, that you use it consistently with that data type. If you try to do something that doesn't work for a particular data type, like maybe putting a string into an integer variable, that's not going to fly. The big four are going to be int for integers, double for decimal numbers. Double stands for double precision floating point, or just double for short. String, which is text data that we've been working with. And note that the S in string is capitalized, whereas the first letters of the other data types are not. And I'll explain why in a bit. And then Boolean is for logical data like true, false, values that allow you to write conditional statements that do something if a condition is true versus if it is false. Also, Boolean logic is the basis behind looping or repetition, so that you'll be able to write a Boolean condition of some sort that tells your code, given the data that you're running with now, how many times do I want to repeat some task. So Booleans are kind of crucial for any type of more sophisticated programming. All right, so creating named variables, we just did this in Eclipse, but the syntax is you specify the data type like int for integers, double, string, or Boolean, and then you put a space, and then you type out a valid Java identifier following the rules that we just talked about. So for instance, if you wanted to create a variable to hold someone's age as an integer, the syntax would be int space age, and then the statement is concluded or terminated with a semicolon. So that's the syntax for any type of variable declaration. So double space golden ratio creates a decimal variable to hold decimal numbers called golden ratio. String, capital S string greeting creates a string variable to hold text values. And then Boolean bottle condition holds a true false value stored in the variable bottle condition. So just note the three key components. There's the data type, there's the identifier, and there's the semicolon. So when you do that, you've created a variable to use, but it's empty. And Java does kind of hate empty things in some ways. They can something that shows up as null, or in other languages nil or void or something like that, can cause Java programs a little bit of little fits. And certainly it does not love variables that have not had some sort of value placed in them, at least as an initial value. And in fact, I don't know if NetBeans does this, but I know Eclipse will warn you if you haven't put an initial value into a variable. It'll come up and say that this variable may not have been initialized. The term is initializing or variable initialization. And so the syntax for doing this is fairly simple. You can see it. It's right here. You type in the identifier for the variable that you want to initialize. You want to put a value in. So for instance, to set someone's age to 27, you would say age =, is the assignment operator. 27 is an actual or literal integer value, and then the semicolon. So all this line is saying is place the literal value 27 into the variable age. This does require that age has already been declared on a previous line, although you can actually roll all this into one line of code or one valid Java statement if you wanted to. So if you wanted to create a variable, specify its identifier, and also initialize it all in one line of code, you can do that. So here's how to do it. Say with a string that you want to put hello in, you could say string space greeting, valid identifier, equals the assignment operator, and then some text value, literal string value in this case, hello, in quotes. You would do the same thing, say, just as a second example, if you wanted to create this bottle condition variable, which is a Boolean, and put the value true in it, the syntax is data type space identifier, space here is optional, equals the assignment operator, space here is optional, and then a literal, in this case, a literal Boolean value, which is true. And then conclude it with the semicolon. All right, so one of the things that, obviously I've got this sticky here to kind of draw your attention to the quotation marks, but you'll see these quotation marks around the string literal hello and how they're straight up and down. But on the slide, if you look up here, you'll see around this equal sign, which is just part of the description of variable initialization, that the quotations are different. They are what's called smart quotes. So they're a different symbol in the character set. Most word processors and presentation programs and such by default will take any quotes that you type in, and the term is educate them, which is simply to tilt them in the correct direction typographically so that they look better. The problem is Java can't process smart quotes as part of the compiler. So if you were to put smart quotes around this term, this string literal hello, it would not work. I only say that because I know people, at least on occasion, like to copy and paste stuff out of the keynotes, which is absolutely fine. But then as I type all this stuff in the keynotes and edit it, frequently Keynote will try to outsmart me and change the quotes to make them look better, but then it ends up with a little chunk of code that you although you can paste it into Eclipse won't run it because the smart quotes don't work. Okay, so we've just created, or we've just talked about the syntax that Java uses to create variables. These are variables that you would use to do, for instance, math calculations, or to write Boolean conditions or Boolean tests to see if something is true or not. That would drive your program to take, action if it's true or false, or take different action if it's true or false. We've also created text data that we would use to build blocks of text, maybe for saving in a text file or displaying on screen, saving in a database. All of these are basic uses for the data types. The other way to create data in Java or in any object-oriented language is to create objects. So objects are bundles of data and functionality all rolled together. Java has tons of built-in classes. It's over 4,000. I've searched a couple times trying to get the exact count, and for whatever reason, Oracle doesn't really advertise that. And you have access to all of these for your programming work. These include all of the graphical widgets that we'll put into our interfaces. So to create a button, as an example, you need to know what the name of the built-in class is, and then you need to know this little bit of syntax, which is called instantiation syntax. So the class that's built into Java to create graphical buttons is called JButton. Notice that the J and the B are capitalized. So the syntax here is name of class, just like where you would put the data type, and then a valid identifier, so I've called it OKButton, the assignment operator, and then the keyword new, and new is what triggers instantiation. So this tells Java to create a new button. The syntax then is the name of the class typically again, and any setup information for objects of that type inside of these parentheses. So as an example, JButtons allow you to specify text that appears as the label on the button, and you can specify that when you create the button optionally. So the syntax to add the word OK to this new button that you've created is just to put the string OK inside of the parentheses. You also could create classes of your own, which we will get to. That's really where the real power starts, is learning how to build your own classes and then to be able to instantiate objects from those custom classes. But let's say that you have a customer class that either you created or somebody in the organization created. You might create a new customer with a given name, something like this. It would be the name of your custom class, which is customer, the identifier C, which is just a valid identifier, the assignment operator, the new keyword, the name of the class again, and then anything that was required to set up new customers based on the customer class that you're using. So in this case, I've got the name of a famous pirate, but obviously that's driven by whoever created the customer class made decisions about what data is needed when you create new customers, and you have to follow those rules. So if I'm saying that this code, works with this customer class, then you would infer that it's okay to send it the customer's name as an initialization parameter in the new instantiation syntax. But that would be driven by whoever wrote the customer class, because customer is not built in to Java. It's something that each business, say, would have to create based on what their customers are like. All right, so using objects, even though we won't get to creating our own custom classes and objects for several chapters, we're still going to be creating and using objects from the built-in classes. As an example, the JButton class. So we need to know how to use the instantiation syntax correctly for the built-in classes, and then once you've created an object like a button, you have to know the syntax to work with it, to do stuff to it in Java, or more generally, most object-oriented syntaxes use the same technique. So the first syntax to know is object.method syntax. And object.method syntax is kind of exactly what it says. It is, you specify the name of the object you want to do something with, then you put a dot or a period, and then you name a method that's built in to objects of that type, and then you send it any information in the parentheses that you want to that method requires. So, as an example, there are occasions where you want to put widgets on screen, but you don't want the user to be able to use them yet, maybe because they haven't made a selection, and you want to have that UI component in your interface so it doesn't pop up weirdly later and rearrange stuff. So you might want to put it there, but disable it until it's an appropriate time to enable it. So there's a method built in the JButton object called setEnabled, and you can pass it a Boolean value, a true or a false, or a Boolean variable that holds a true or a false. So the syntax, if we had that OK button that we had set up on the prior slide, but it wasn't ready yet for the user to hit because they still need to fill something out or make a selection from a drop-down box or something, the syntax is the name of the object, OK button. So not the class name, the name, the identifier you gave this object. which on the prior slide was OK button. Then the dot, then the name of the method that we're calling. So the method is called setEnabled, and then we pass it false, which will disable the OK button. So if we have over 4,000 classes and each class has dozens or in some cases hundreds of built-in methods, there's a lot of functionality that's built into Java ready and waiting for you to use. So you don't have to define setEnabled. It's a method that's built into Java. It comes with it. When you create buttons, one of the features that you get is this method that exists that enable you to enable it or disable it visually on screen. And more than that, a disable button can't be pressed. So you can't get weird button press events that you have to filter. A disable button is grayed out and does not work. In the classes that we create, like customer, you'll have to put your own methods in it. You'll have to decide what are the methods that are important to customers in my organization, and then you have to define, and test all of those methods. But as an example, if we had a send invoice method that allowed you to send an invoice for a certain amount, maybe the syntax would be object name C from the prior slide, dot, method name, maybe you called it send invoice, and then in parentheses, maybe you pass the value of the invoice that you want to send your customer. Moving on, the next slide up is definitions. So when we write Java programs, there's all sorts of terminology to be learned or perhaps relearned in a new language a little bit. But these are the main pieces that we've been looking at so far. Literals, variables, operators, expressions, and statements. These are the key elements that we've been using so far to write all of the example Java code that we've been writing. So a literal is an actual value of a particular data type, like the text hello in quotes would be a literal string. A variable is a named entity to store a changeable value. So when we created the variable age to store someone's integer age, that we could then use later to test to see, for instance, is this customer or whatever it is old enough to do something or young enough to do something or whatever you're using text or whatever you're using age to drive. Operator is a symbol or character that represents some action. So we've used the equals operator, which is also called the assignment operator. So the single equal sign tells Java to take whatever's on the right-hand side of the equal sign and store it in the variable on the left-hand side of the equal sign. That's the assignment operator. We'll go over other ones in just a second. An expression is some bit of valid Java syntax combined together. It could really be just about anything that doesn't produce a red underline in Eclipse. And then a statement is a complete instruction that Java can actually execute and move on from. These are going to be terminated with the semicolon. And then obviously statements are typically made up of one or more expressions. Programs essentially are lists of instructions that are executed step by step, one at a time, typically top to bottom. So a Java program is essentially, at its core, is a sequence of valid Java statements that the Java runtime environment reads, interprets, executes, and then moves to the next statement, and then continues to execute statements and move down your code statement after statement after statement. Expressions can be super simple. Just again, it's any little bit of code that Java can evaluate. So if you had some math as part of an expression, say 2 plus 2, Java can evaluate 2 plus 2 and get the result 4 and then move to the next part or the next expression or the next part of the expression. They can also be a little more complex. So I have an example here of just a little bit of code that's a little bit more involved at this point. If we went back to the recipe, you saw we put in something called DME into our root beer recipe, and it's in pounds. But maybe we only have data on kilograms of these components. So we need to do a little bit of math to convert the kilograms into pounds, and you do that by multiplying by 2.2. So if you had a statement like this where I wanted to calculate some value in pounds, I call it pounds of DME, and I set it equal to the assignment operator to this expression. So on the right hand side of the equal sign, we've got an expression that is a literal number, an asterisk, an identifier, a plus, a literal number, an asterisk, and then a second variable name or identifier. And so this works a lot like writing expressions in a spreadsheet or in other languages. The difference will just be learning Java's little quirks about syntax and also just refreshing your memory about how statements like this get evaluated. But in concept, this is just a little bit of math that says, hey, multiply these two variables by 2.2, add them together, and then take that result and store it in the variable pounds of DME. That way later in the program I can use pounds of DME and not have to do this math. So let's zoom in on this statement and tie them to the definitions that we just had. So there's a lot going on here, but it's color-coded so that you can hopefully see the different pieces easily. But I know there's lots of colors, and I didn't necessarily pick the best, most attractive colors, I have to say, looking at that now. But I've used orange to identify 3 variables, and you can see that they're pounds of DME, light DME, and amber DME, and kilograms, kg light DME, and so on. So those would have had to have been declared and initialized prior to this line for everything to work perfectly. You'll notice that there's no data types here because we're not declaring any of the variables, we're using them. The literal values I've got in purple, so you can see there's 2 literal values. These are actual bits of data, an actual number, an actual piece of text. So there's 2.2 in both cases. I've got operators in gray. I don't have arrows going to them just because the amount of arrows got out of hand and covered up. I couldn't figure out how to put arrows everywhere and not cover up a lot of what I was trying to do. But you can see the operators are the equal sign, which is the assignment operator. I've got an asterisk, which is multiplication. I've got the plus, which is addition. And I've got the second asterisk, which is multiplication. Sorry, and I've got the semicolon at the end, which terminates the statement. I've got a table coming up pretty quickly on the operators, the math operators, but again, they kind of follow what you're used to in other languages, or even if you just know spreadsheets, what you would do in a spreadsheet. The expression I've got, I don't even know what you call that color. I don't like it, but it is what it is. But whatever color that is, everything to the right-hand side of the equal sign is a valid expression. So Java can process that and get a result, which makes it an expression. It isn't by itself an entire statement because it doesn't do anything. It's just a bit of math. The entire statement requires Java to be able to take a complete step, which would be to do the math and assign it into a variable and then be able to move on. So all of this together, this light blue code that's enclosed in these braces to kind of define it visually for you, all of this is together a complete Java statement. One of the things you'll start to get a hang of or need to think about if you don't already have any experience doing this is just, okay, what order does all this stuff happen in? Because if you don't know what order Java's going to do stuff in, then it's hard for you to write your code where order is important and get the sequence correct if you're not sure how Java's going to do what it does. So I'll talk about execution order a lot, and more generally flow of execution, which is sort of where does Java's gaze fall to do work before moving someplace else to do that work. In a statement like this, there are a number of rules. It's a math statement. So first off, Java will do everything on the right-hand side of that equal sign first. And then in the expression on the right-hand side, it will move from left to right. Although if there are parentheses and such, it will allow you to override what happens, but in general, it moves from left to right and it obeys normal mathematic precedents like spreadsheets or any other language. So given that we've got this multiplication as the leftmost part of the expression on the right-hand side of the equal sign, that green 2.2 times kg light DME, that math will be done first. Then Java moves to the right, but it's got a second multiplication, so it does the multiplication next because that's mathematic precedence. It does the second multiplication, and then as the third step, it adds those two results together, at which point it's completed processing the right-hand side of the equal sign. It has fully executed the expression that we've put there. So the next step is to move on to whatever operator is here, which is the equal sign, the assignment operator. So as the fourth step, it puts that result into the variable that you've created. And then as a fifth and last step, it's done, semicolon, moves on to the next statement. So these are the basic operators. We've used addition, we've used multiplication, we've used assignment. There are other ones that are very, very commonly used. I don't think anything would be a surprise here. We'll cover all of the ones as we get to them in the chapters on math. All right, strings are a bit of a special case, I guess. We do a lot of stuff with text. It's an important part of writing programs. And they're a special case because they're based on a class, not on what's called a primitive data type like int or double. So there's a convention in naming in Java that I didn't mention, which is class names are capitalized. So if you see what you think is a data type in an expression, but it's capitalized, what that should signal to you is that's not one of the basic primitive data types like int or double. Rather, it's based on a class. So I think I pointed out the first time you saw the word string that it was capitalized. So if you're following along with the video, you can see the S in that declaration box. The S is capitalized. So that means string is a class. What that means is greeting is something that was created from the class or something that will be created from the class, which makes it an object. It's weird because you might remember that I said a few slides back, and you might not remember this. There's a lot of detail in here that we're skimming over, but you might remember that we create objects from a class using the new instantiation syntax. That the syntax was something like class name space identifier equals the keyword new, which triggers instantiation, and then the class name, and then in parentheses, then any other data to initialize the class. I said that's how we create objects. That's the instantiation syntax for Java objects is to use this new keyword. And yet, I'm not doing that. If you're looking at the screen, what you see is I've got a declaration box. I've got the initialization box, which uses an equal sign, but you notice there's no new keyword. The class name is not repeated. There's no parentheses. Rather, it's written out just as if it were a number, like int age equals 27, semicolon. But it's not. So I've told you it's not, and yet this is the syntax that I'm showing you, and that works fine. You can combine these two steps together like this. Data type, which in this case is a class-based data type, if you want to say it that way. Identifier, assignment operator, literal value, semicolon. This works fine. It violates basic object-oriented syntax, and the reason essentially is that Sun decided you create so many strings, we might as well allow the programmer to treat them as if they were just a normal data type, because having to type out the new instantiation syntax every time is a pain, and we're going to do this so much, we'll just allow the compiler to convert it into the correct syntax as it parses through the code. But you can actually use the full instantiation syntax with strings, and I think we'll do that in chapter 7, so you can skip ahead to that if you want to see how it's done. But the key takeaway is that Java breaks its own rules sometimes, which hardly seems fair because it enforces them when you try to break them, rigorously. but it can sometimes be a little bit fast and loose. But in this case, the goal is to make using strings easier. When thinking about strings, the equal sign is still the assignment operator. So if we wanted to put Java rules into a string variable called armado, or string, technically it's a string object, armado, and then the plus operator works. If you wanted to append two strings together or concatenate two strings together, combine two strings together, however you want to say that, we can use the plus sign, you see right here, to do string concatenation. So if we say armado equals armado plus C# rules, we should get Java rules, C# rules as the result. And if we system out print lined armado, we should get that as the result. So I said I'd get back to Eclipse, and I haven't really, but let's just do a little bit of this. So if you want to follow along, and there we go, string armado equals Java rules semicolon. So what I've got on line 4 is now a full and complete Java statement. It creates an identifier called armado to store string objects and puts the string value Java rules into it. If I want to do a little bit of concatenation, I could say armado equals armado plus C# rules. So we're getting an error here because there's only certain things we can do at the location I'm typing in, and we'll get to details on that later. But this is actually doing some operations other than assignment, and essentially you're only allowed to do assignment, declaration and assignment here at this part of the code, which is outside of any method. So there's a couple ways to fix that. The easiest one right now is just to add an extra set of braces. This syntax is a little bit odd and is a newer syntax, and if it doesn't make sense, don't worry about it. We will cover all of this in detail later. I was just trying to get a bit of code that actually worked. So we've got armado declared and initialized, and then we've also done something with it. We've used it. And if I wanted to then see that at the console, I could, for example, say hello app equals new hello, and then I create a method called hello, and then to move that into that method. So to run it really quickly, we should just see my name and then our motto at the console. We will go over this in detail. There's essentially, I'm following a template for basic Java apps here, which is set up some variables, set up the app, and then in the app, do your actual work. And we'll go over this in detail, and you'll get used to where you can put certain code and where you can't. You know, what we've covered so far is the basic language of writing a statement and what a statement is composed of, what it looks like in Java, you know, the use of the mathematic symbols and the semicolon and the assignment operator. And that's enough to write a simple program which would execute statement after statement after statement after statement to get something done. The next step in programming is to use logic to control which statements get executed. And we do that using logical conditions, and those are composed of logical values, trues and falses, and Boolean operators, which are listed here in the table. So you can combine values and operators and Boolean literals to figure out if something has happened yet, or is about to happen, or is never going to happen, and then execute the correct code based on what the result of the Boolean expression is. The result of a Boolean expression is, it always boils down to a true or a false. So any complex logical condition that you look at, if it's compiles and is written properly, it will evaluate down to a true or a false. And then we can use if-then statements or looping statements to control the flow of execution so that it isn't just purely kind of top-down step by step, but it can jump around. The Boolean operators in the table are just the basic Boolean operators as they appear in Java. These may not entirely be I mean, they're not consistent necessarily with every other language, and there's some places where I feel like I wish it wasn't the operator. Like, for instance, the logical and is this double ampersand, and the logical or is this double vertical pipe. Why isn't it the keyword and the keyword or? I don't know. I don't know. So sometimes I feel like I should be apologizing for it as if it's my responsibility, but it's not. But it is what it is, and you do get used to it fairly quickly. Okay, so just as a running example in the chapter, I say we've got this recipe. We're creating a beverage, and one of the steps is to boil the mixture, and you have to boil it for 90 minutes. So, key idea here is that if our program was running and controlling some sort of an industrial kitchen process, we would need to have a timer going, and we would need to keep track of the value on the timer, and we would need to obviously stop the boiling when we hit whatever the preset time is, and the recipe is 90 minutes, I believe. So we could ask a question using Boolean logic just to see if the boil timer, if that's counting in minutes, is greater than or equal to 90. So that would be what's called a Boolean test or a Boolean condition. It would evaluate to a true or a false. Either the boil timer is greater than or equal to 90 or it's not. And there's no fuzzy logic here. It either is or it isn't. The result is a true or a false. And then that will be used to drive what happens in the program. So we do it two ways. One with something like an if-then statement, which is common to all programming languages. The syntax is a little different maybe in Java. So the syntax requires, well, the keyword if, lowercase I, it can't be uppercase. You have to have these parentheses. So after the if, there's an open parenthesis, and at the end there's a closed parenthesis. Inside is the Boolean test or the Boolean condition that will evaluate down to a true or false. And then for most if statements, you're going to use an open curly brace and a closed curly brace to surround the statements that you want executed for a true condition. So if the test is true, you'll execute those statements in between the curly braces. So it could look something, this is completely made up, a completely made up method, but I assume maybe if you do actually have a programmed industrial process like this, that you have methods that you call to turn certain things on and off. And if you had a method like do shut off stove, and you wanted to call it when the boil timer hit 90, you would write it something like this. If boil timer is greater than or equal to 90, open brace, do shut off stove, which just calls this fictitious method, and then close brace. The other common thing we do with Boolean logic is repetition, which is to do something repeatedly over and over again. Looping is it's sometimes called. Java has the three common looping structures you've probably used and learned in a previous language, and we'll go over them in detail. What I've got here is an example of a while loop. So I'm assuming that the recipe calls for the mixture in the industrial pot to be stirred during the boil time. So if we want to stir the pot and assume we have a method set up called stir the pot, again, completely fictitious, made up, just to give you an example of the syntax. You could write this stirring code something like this: while not, the exclamation point is not, boil timer greater than or equal to 90. So that just says if the boil timer is not greater than or equal to 90, stir the pot, which is consistent with what the recipe asks for. That is, until the boil timer expires, keep stirring the pot. Call that method stir the pot over and over and over again. Again, we've got an entire chapter on Boolean logic, if-then statements, and repetition structures coming up in a bit. Like I said, there's a ton of built-in methods in Java. We will frequently use them using what's called an object.method syntax, which is we'll address an object that we've created in our program and then use a period or a dot to access methods that are built into that object. So this is now not a fictional method. That is a method that's built in, and I'll show you how to use your IDE to learn more about the built-in methods in Chapter 3. The other thing is you can make your own methods. That's to some extent the power of most programming languages, is to take code that you've written and tested and works, and that you know you'll need to use multiple times during the running of a program and to move it into a named method that you can call or invoke anytime you want to run that code. So object-oriented languages, these are generally referred to as methods, but there are other names. And if you learn BASIC, some form of BASIC, they're called functions. If you learn other languages, they're procedures or routines or subroutines. And there are even some other odder names that I've seen over the years. Java refers to these as methods. If you took the mobile development course, Lua refers to these as functions. And the syntax is slightly different than maybe what you're used to. But the real key is to be able to write your own methods and then call them when you need to. And we'll cover this in detail in Chapter 9, but I just wanted to give you just a little example, again, a taste of the syntax so that when we get to Chapter 9, maybe it's a little bit more familiar to you. So this is pretty much a worthless method. I needed to find something that would fit on one slide, not be overwhelmingly, complex, and illustrate the key features of a method. So we previously had to do this little bit of math where we were converting from pounds to kilograms. We had to multiply by 2.2. Let's say you just have to do this a lot and you don't like typing the asterisk. Maybe, I'm not sure, but you don't want to do the math. Rather, you want to write a method to do the math for you. So what you're seeing on screen, double convert to pounds, is a valid Java method. Its name is convert to pounds. It does a calculation based on data that it receives. So it receives a decimal value as a parameter, and then it multiplies that decimal value by 2.205, which is just slightly more accurate a conversion. It assigns the result of that into a variable called value, and then it returns that value as a double decimal number. There are a number of advantages to using methods, including reducing repetition in your code, duplication in your code, redundancy in your code. Redundancy, places in your code where you do the exact same thing as you've maybe even cut and pasted it from multiple locations, is a way to attract bugs. So we do try to not cut and paste as much as possible. To call the method, again, you need to know the method name. It was convert to pounds. So to do that same calculation we had earlier in this slide that we broke that statement up into its little constituent elements. We had two values in kilograms. We needed to convert them to pounds. We needed to add them together and convert them to pounds. If you wanted to use this new convert to pounds method instead of actually doing the math yourself, it would look something like this. You call convert to pounds, you send it the values in kilograms that you need to convert. Here I'm adding them together to get a total kilograms, and it will do the conversion, that is multiply by 2.205, and then send that decimal result back and store it in this variable pounds of DME. Again, we have an entire chapter set up to look at creating your own methods, what the syntax variations are and the design kind of ideas are to make it useful. I want to stress that this chapter is to give you a big high-level overview. It is not my expectation coming out of here that you now all of a sudden know how to do all of this.